Hi everyone, today I will explain scientific notation. Scientific notation basically is using for scientists to express large or very small quantities or very small numbers using less digits. For example, if we want to find the distance between the planets, we have a large quantity or a large distance, so we're going to use scientific notation to express that distance without that zero. So we're going to use scientific notation. Or for example, if you want to represent a microscopic quantity, so we are going to use scientific notation to represent that quantity without many zeros. So, but for scientific notation, we have some rules. If we move to the right, we are going to use a positive exponent. If you move to the left, we are going to use the negative exponent. And another thing that you have to identify in scientific notation is the coefficient. The coefficient is before to the sign of multiplication. Then we have the base, and that in this case we are going to use base 10. That this base means the number of times that we are going to multiply that number. For example, here we have 3, that means that we are going to multiply 10 times 10 times 10. And when you multiply that number and you multiply by this one, you're going to get the zero that we reduce using the scientific notation. For example, here we have the population of Arizona. We have the weight of the earth in kilograms, and we have another two examples. In this case, we are going to pass from a standard form to scientific notation. A standard form is when we have all zeros, when we have that zeros. And scientific notation is when we have in this way. Now, for example, remember, if we move to the right, we are going to use positive exponent. And if we move to the left, we are going to use a negative exponent. So in this case, we are going to write from standard form to scientific notation. How are we going to do this one? First, we are going to write the first two numbers, 7.2. Always we're going to use the first two numbers, and we are going to write a point between them. And then we are going to start the number of places that we need to move until the end to get the exponent. So for example, 7 and 2, we are going to write a point here, so that's the reason that we write 7.2. So, and then we are going to start to counting. 1, 2, 3, 4, 5, and 6. We move until the end, so in this case we move 6 units, so it's going to be 7.2 times 10 to the positive 6. It's positive because remember we move to the right. So in this case, our population of Arizona in scientific notation is 7.2 times 10 to the 6th power. Remember, this 6 means 10 multiplied by 10 by 10 by 10 by 10. With this quantity, we are going to get all that zeros. Now here we have the weight of the earth in kilograms. So how are we going to do that? So first, remember, we are going to write 6.0. In this case, we are going to write 6.0, 6 equal 6.0, and then we are going to start to counting the number of zeros that we haven't. So how are we going to do this one? So we are going to counting 1, 2, 3, we counting 1, 2, 3, and then 4, 5, 6, 7, 8, 9, and then if you count it until here is going to be 12, 15, 18, 21, and 24. If we move on to the end, so it's going to be 24 places, and it's going to be 6.0 times 10 to the 24. Always we're going to use the base 10 with this scientific notation, because 10 means 10 times 10 times 10 times 10. And with this quantity, we are going to get all those numbers. So here we have 52 and all the zeros. So we are going to write first 5.2, 5.2 here. And then we are going to start to counting the number of zero or places that we need to move it. So in this case, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it's gonna be 5.2 times 10 to the 11th power. Because we moved to the times 10 to the 11th power. So it's going to be equal 5.2 times 10 to the 11th power. This is our answer in scientific notation. Now, this number, you can start to move the number from this one. You're gonna start from the 23. Remember, it's going to be a point between them. So it's going to be 2.3, 2.3. And then we are going to counting until this number. So it's going to onto this position. So it's gonna be, remember, here is the point. So we are going to counting 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's going to be 2.3 to the 9th power. But in this case, it's going to be negative, the power, because we move it to the left, times 10 to the negative 9 power. And this is going to be our answer, so equal. So remember, if we move to the right, we are going to get a positive exponent. And if we move to the left, we are going to get a negative exponent. Always when we have the two numbers at the end, we are going to use a negative exponent. Okay, now, as you can see here, we have scientific notation to a standard form. In this case, we're going to do the backward process. For example, here we have 1.9891 times 10 to the 30. That means that we need to move it 30 places. So we're going to have equal. Here we have the first one. It's going to be 1, 2, 3, 4, 5, 6, 7. And then 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. And then we are going to take out this number, and this is going to be the solar mass in kilograms. So kilograms. And then remember, you have to count in the 3 by 3 to locate the decimal number. So it's going to be 3, and then another 3, and then another 3. Remember to represent thousands. So here, the other 3 decimal places, and then another 3 here, and then another 3 here, another 3 here. Okay, and it's going to be this number, large number. That's the reason that scientists use scientific notation to represent that quantities. So here we have 9.3 times 10 to the 7. So in this case, that means that we have 9.3. And remember, we need to move to the right, so we are going to add 0. 1, 2, 3, 4, 5, 6. Well, let me check it now. 1, 2, 3, 4, 5, 6, and 7. So we add 6 zeros to represent that quantity. So it's gonna be this one. I think this distance is in kilometers. Now in this one, as you can see, we have 10 to the negative 15. 10 to the negative 15, you can write it as 1.0 times 10 to the negative 15. 10 to the negative 15 and 1.0 times 10 to the negative 15, it's the same. So remember, this is negative. Okay, so how are you going to write this number in a standard form? Remember, this is going to be a short quantity because it's negative number. So remember, we need 15 places. So we are going to write equal. We're going to write 1, for example, and before to 1, we are going to write 0 point. And then we have to move it 15 units, right? 1, 2, 3. I'm going to count in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And it's going to be 0.000001. So if you want to divide this one, or if you want to count it, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, and 15. So 15. So here is a 0. I added an extra 0. and this is my quantity in standard form, so it's going to be meters. Okay, so basically this is the topic, and remember, if you move to the right, you're gonna get a positive exponent, but if you move to the left, you're gonna get a negative exponent. I'm gonna give you an extra exercise. For example, if you have 0.0000234, always need to be between the two numbers. If you have 234, it's gonna be 2.34, and then you have to count it. Okay, so here is the point 2.34, so it's gonna be 1, 2, 3, 4, 5. So it's going to be 2.35 times 10 to the negative 5. Okay, or for example, if you have this one, I'm gonna use 532. In this way, if you want to write in scientific notation, we are going to do it like this. Remember, first you have to write 5.32. Always you're gonna write 5 point and the other numbers, because these ones are called significant figures. And then we are going to do the movement. So we're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 11, 12, 13, and 14. So it's going to move, we move to the right, so it's going to be positive exponent, 5.32 times 10 to the 14 power. Okay, and this is in scientific notation. Remember, standard form is when we have from scientific to the large quantity or to the short quantity. And remember, basically scientific notation, it's using to represent small or large or very large quantities.